Alright, so we talk about the R and S configuration at a chirocarbon. If I am to have a chirocarbon, I need to have a carbon that is linked to four different things. Then I'm going to say that is a chirocarbon. Not same things, but four different things. The way we have got this one has got four different things. Let me put this as CH2 CH3. So we can see all the atoms here are different. Now if I had to put a mirror at this position, reflection is going to happen such that this carbon, the CH3 is going to be this direction, the hydrogen is going to appear here, and then the bromine will still be down, the ethyl group is going to be on top. So these two groups, they are non-superimposable mirror images. Consider your hands. The hands are non-superimposable mirror images because they look exactly the same. But if you make sure that the palms of your hands are facing down and then you get one hand and put it on top of the other, they are not going to be able to fit even if they are mirror images of each other. So that is what we call non-superimposable mirror images. When I want to determine the R and S configuration, I need to make sure that I rank the atoms directly linked to the chirocarbon from 1 to 4. Bromine is going to receive position number 1. And then between this one and this one, we can see both have got a carbon direct linked to the chirocarbon. So we consider the atoms which come after these two carbons. Here they are all hydrogens, but here we have got hydrogens and a carbon. So meaning this is going to receive position number 2 because carbon has got a higher molar mass than hydrogen, and then this will be 3, and then this will be 4. Now I need to make sure that the fourth group is in the back. So this one I'll just leave it like that because the hydrogen, which is the fourth group, is already in the back. So the configuration of this one we can see is going in the anti-clockwise direction. This is more towards the left. Okay. So this is going to be given as the S when it is going towards the left. Now if we name these carbon atoms, which one is going to be the first carbon? Carbon number 1 is going to be here, carbon number 2 here, carbon number 3 here, carbon number 4. The second carbon we have got a bromine, so the name is going to be S2 bromo. This has got 4 carbons, butane. That is going to be the name. And then the other one is still carbon number 1, number 2, number 3, but this one is going in this direction, in the clockwise. So this is going to be the R. This is going to be R. At position number 2 we still have a bromine, so R2 bromo butane. So this is how you determine configuration, either being S or being R. Let's consider another one. Let's say I've got a carbon and this carbon is bonded to a methyl group first. Then we have got CH2OH, and then we can have a bromine here, and then we can have CH2CH3. What will be the configuration of this one? Which one is going to be the first group? Definitely this is going to be the first group. And then these others have got a carbon direct link to the other carbon. So to determine which one is going to be the next, if you consider this one, you have got a carbon, it has got hydrogens, and then a carbon, and then hydrogens, 3 of them. And then for this other one, you have got a carbon and 3 hydrogens. And then for this one, you have got a carbon, 2 hydrogens, and then an oxygen, and then an hydrogen. So if everything is the same, this is the same, you cancel them. These are the same, you cancel them. These are the same also. Okay, they are also going to be cancelled. But look at what comes next. This is oxygen. So oxygen has got a higher molar mass than carbon, and then carbon than hydrogen, meaning that this is going to be the second group, this is going to be the third, this is going to be the fourth, and the fourth group is already at the back. So meaning the configuration of this one, I'm just going to go in this direction. So then what will be this one? It's going in the anti-clockwise direction. So this is the S configuration. Now let me name this compound. Which one is going to be carbon number 1? So you consider where the alcohol functional group is because it has got higher priority. So this is going to be carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So this is going to be, we said this is going to be S. And then we have got two groups, this side and this side. A B comes first than a C in the alphabet. So this is going to be S, 2 bromo, and then we have got 2 methyl. This one has got 4 carbons. I can say butane. Position number 1, I've got alcohol functional group, butane 1O. So that is going to be the name, or I could have said S2 bromo, 2 methyl, 1 butano. So that is going to be the name of this one. Now what happens if the fourth group is not in the back? Then how do you get to name such a one? So let's say I've got a carbon here, and then I've got alcohol function group at this point. Let's say I've got a methyl group here, I've got an ethyl group on top, and then I can say a chlorine here. What is going to be the name of this one? Now in such a case, if we get to prioritize this, this is going to be number 1 because chlorine has got a high molar mass, followed by oxygen, and then followed by this group. The fourth group is in front. So this was supposed to go like this. This is supposed to give us S. But because the fourth group is not in the back, we are going to reverse configuration. So this is going to be R. So what is going to be the name then? So when you are counting the carbons, this is going to be carbon number 1, carbon number 2, carbon number 3, and number 4. Carbon number 2, so this is already, we've said R. At carbon number 2, we have got a chloro. So R2 chloro, and then we have got at carbon number 2, the alcohol functional group. So this is going to be R2 chloro 2 butano, or R2 chloro butan 2O. That is going to be the name. Let's consider another one. Let's say I have got, at this point I have got, what can I put here? I can have this, and then let's say I have got, okay, let me say I have this one, then I've got another one here. What is going to be the name of this one? Now if we consider, we first need to determine which one is going to be the chiral carbon. This carbon here, even if this one is in the back, this one is in front, it's not going to be chiral. Why? Because these two groups are the same, so I don't expect this to be chiral. A chiral carbon should be bonded to 4 different things. So then I'm going to consider this one. We have got this group which is in the back. Well, then which one is going to be in front? Well, even if we can see hydrogen here, hydrogen is there and it is the one in front. So then this is going to be position number 1 because we have got oxygens. Now between this carbon and this carbon, direct linked to this carbon, which one is going to be the next group? The next is going to be this one because it also has got other groups which will increase the smaller mass, and then this is going to be the third group. So this one is supposed to go like this. Okay. So the name, the configuration of this one was supposed to be R. Now because the fourth group is in front, we are going to swap. This is going to be an S configuration. So that is how we basically determine the configuration also for this one. There is also a swap method of us determining the configuration. Let's say we have got a carbon, we have got alcohol functional group here, we have got, let's say, an hydrogen, and then in the front I've got a methyl and then a bromine. Let's name this compound. Position number 1 is this one, number 2 is going to be this, number 3 is this. Now you can see the fourth group is not in the back, so this was supposed to be named in this direction. So we can see this is going in the clockwise direction, so this is supposed to be R. Now because the fourth group is not in the back, then this is supposed to be S. Okay, now another thing that I'm able to do is using the swap method, I'm going to swap two groups in such a way that the fourth group I take it to the back. So I'm going to swap these two. So what is going to happen is that the alcohol functional group comes here and then the hydrogen comes here. If I swap this one group, I also need to swap these other two groups. So then the methyl is going to come here and then the bromine is going to come here. So this is going to be position number 1, number 2, and number 3. So we can see this one goes in this direction. So what will be the configuration of this one? This is the S configuration. The fourth group is already in the back. So if you make two swaps, you swap this and then you swap this, the configuration is going to be the same as the actual configuration. So if I swap once, if I just swap this and this, what I'm going to get is an enantiomer of this compound. But if I swap two times, they are going to be the same. I swap three times, I get enantiomers. Four times is going to be the same. Five times enantiomers. Six times the same, just like that. Okay. So let me try to have another one. Let's say we have got this compound like this one. What is going to be the configuration for this compound? We know this is going to be the chiral carbon, and carbon number, the first group is going to be this one, followed by which group is going to follow? Okay, in this case, the next group is going to be this one because it has got a higher molar mass in comparison to these others. Now, let me put, okay, just like this. This is supposed to be the second group. Which one is going to be the third? The third group is supposed to be this one, and then this is going to be the fourth. Now, because the fourth group is in the back, what is going to happen since the fourth group is, it is in the front, not in the back. So when you are naming, this was supposed to go in this direction. This was supposed to give us what? Supposed to give us S. Now, in this case, if you make any two swaps, it's supposed to change. Okay, those swaps, how do you get to make them for such a compound like this one? So in this case, if I want to swap for this one, let me swap these two groups which are here. Then one is going to come, let's say this one is going to be here, and then the CH3 is going to be here. I also need to swap these two groups if I want to get the same thing, meaning that this is going to come here, and then so this one has gone to the other side and then this one has gone to the other side. So I've made two swaps. So this is going to be position number 1, position number 2, position number 3, and then number 4 is in the back, as we're able to see. So this is going in this direction. What is the configuration? This is the arrow configuration, same as this one. This one was going in this side, but because the fourth group was not in the back, we said you need to swap configuration. So this is also arrow configuration. So this is how you are able to swap to make sure that you determine configuration. Let me just mention the last example in this practice. So let's say we have got a carbon which is bonded to another carbon which has got alcohol function. Okay, it has got this functional group, and then this carbon here, let's say it has got a methyl, it has got CHOH, and then I can also put, let me just put just any other compound here. What is going to be the configuration of this one? This is going to be position number one is going to be this one, followed by this one, and this one. The fourth group is going to be here. So the configuration, let me remove the fourth group, is going to be like this. What is this configuration? So this is the R configuration, and that is how you get to determine the R and S configuration.